Right. Well, welcome to wasmCloud Wednesday, first one of the month of February. We've got two demos today, and we're going to run through a series of updates of where we're at on WASI V2, a little bit on the procedures of what we're going to do, transitioning from the WASI repos, our V2 repo, over to the wasmCloud repo. But first, let's talk a little bit about what we're working on right now, which is basically exercising V2 in a variety of ways. And one of those is making sure that we've got templates built so that other people can build with them. And Eric created a set for TypeScript. Eric, you want to run through those?
Sure thing. So I will go ahead and replace the share with me. There we go. And let's talk about the background here a little bit. So we're in the last stretch for WASI V2 and for documenting WASI V2. And a big part of that is coming up with templates that users can use to create new applications, examples that users can use to see how you're going to build with WASI V2. And several maintainers got together and talked about how we want to have some conventions around these examples to try to give an order to them, make them more usable. So philosophically, we want these to be, especially these pieces we're calling templates. We want them to be robust. We want them to demonstrate enough functionality that you can build real apps with them. We also want them to be approachable, meaning we prefer standard and idiomatic approaches where possible, using things like WStud for Rust, JCoStud in TypeScript, standard web APIs like Fetch. Basically trying to keep using generated WIT bindings kind of down under the surface where it belongs. And in addition to those kind of broad philosophical goals, we developed a couple of conventions just around the way that we deploy and host and organize and arrange these templates. So they're going to use explicit names based on their interfaces. So I've got three examples here. I've got HTTP Hello World. It says we're using the HTTP interface and we're creating a very minimal Hello World. And HTTP client. And then we've got another one called HTTP Service Hano. And each of those tells you exactly what interface it's demonstrating and says what it does on the 10. So in addition to that explicit naming convention, we're going to, in each of these, have config YAMLs for Wash that enable automatic dev and build upon download. And you can download them with Wash new, pointing to the Git repo. Every individual template is going to have its own git ignore, and the contents of that should be standardized and differ somewhat by language toolchain, but typically they're going to exclude things like WIT dependencies, generated bindings, and with that in mind, templates should be configured to fetch WIT dependencies and generate bindings on dev or build. So for our HTTP Hello World here, you can see an example of what that looks like in TypeScript. We also, in our world.wit files, want to use standardized package and world names. So you can see here, our package is wasmCloud templates, and our world is TypeScript, giving us the language, and then the template name. So just bring a little order here. Last requirement that we've got for our templates is that we have a README, making sure that this is usable, approachable to everyone. So the hello world here is maybe the exception on this idea of being very robust. This is designed to be a very minimal, simple application that we can use in a quick start. So all it's doing is returning hello from TypeScript. But look here how we're using the fetch API. This is a very simple 9 lines of code here. Really just 7. So we're trying to do things in a very approachable, easy to understand way for someone just figuring out how to work with components. So let's look at one that's a little more robust. This is our new TypeScript HTTP client example, or template rather, that's underway. And let's we're also using the fetch API. And let's take a look at what this does. When we run wash dev, we fetch the WIT dependencies, generate the bindings, and then, all right, we're running. So I'll hop over to another terminal window. And you see we've got a good deal of functionality here. So this component makes outgoing HTTP requests using the standard fetch API. We've got several endpoints, one for making requests, one for proxying requests and returning formatted JSON, one for proxying requests and returning response headers. And then we can do this with our various methods. And then we can use any of these endpoints, adding URL and forwarding the request to the specified URL that just uses HTTP bin by default. So we can see a quick example of that. So we're doing our basic HTTP client stuff. And hopefully this gives users a kind of a scaffold to start working within TypeScript, doing it in a really standard, understandable way, and quickly generating components that can run in wasmCloud v2. And
Eric,
yeah,
will you talk a little bit about the difference between templates and examples?
yeah, that's a good point. So templates are meant to be these robust kind of scaffolded um, starting points for developers. So this is supposed to be a utility for a developer. Examples might be more fleshed out than that. So they might be a sort of flashy demonstration of some particular combination of functionalities that really show off everything that you can do when you're working with wasmCloud. But these are designed for developers to kind of get their hooks in and get started, but to do meaningful work with that.
Yeah, so as y'all can see, Eric has added this new templates directory as part of his pull request to our TypeScript repo. We will need to do this for Go, for example. We have a Go repo in wasmCloud. And Lucas has been working on expanding out our Rust templates and Rust examples in where we're going to keep basically all Rust stuff is going to stay in our mono repo. And the mono repo is going to be a cargo workspace managed repo. So only cargo examples there. And so inside it, we'll also have an examples directory and corresponding templates. And we also aim to have it where if there's a template of it in TypeScript, we're aiming to also have a template of it in Rust. So they'll have common names. You can kind of guess what they'll be without necessarily having to go and look it all up. They'll all kind of use that same Rust hyphen HTTP hyphen client template. Cool. I think we might as well, since we've got you, Eric, also highlight Doc of the Week. Wash V2 RC7 is now out, and you revved all our docs. So please give us feedback if the docs aren't lining up with what you expect. What was really helpful with Eric going through the docs is when he revved it for RC6, we saw some bugs that we needed to fix and got those in. And so now it looks like what we want, and I believe we're basically feature complete. So we're entering kind of hardening stabilization and improving developer ergonomics by providing templates and examples. So what's next? You might have seen also that Victor's been revving wasmCloud v1. And over on the wasmCloud v1 side of the world right now, that's wasmCloud/wasmCloud. And until we were ready to cut a v2, we didn't want to, rock the boat between these two different kind of views of the world. Right now, Victor's running through and cutting what we think is basically the last release and wash, thank you, of the wash v1, a wash that is for v1. It is getting cut right now, right, Victor? Actually, if you want to talk about that, you're welcome to. But if not, I can also keep talking. Essentially, he is cutting that release right now. Once that happens, we're ready to start this reconciliation effort. I think we'll probably begin that next week. And what that'll basically look like is we're going to move the body of what's in wasmCloud v1, that basically the state of that current repo, into its own repo. And we're going to take what's in wash, what's currently in the wash repo, and put that in wasmCloud, redo the CI, republish things, and then we might launch. So please come in and give us feedback. Let us know how things are working, and know that I'll make a call in Slack once we start this reconciliation. because then it's basically gonna hit pause on cutting both release candidates and wasmCloud v1 until we finished revving everything, basically. So that is that part of it. Anybody else, any maintainers want to add on that state of the world? Anything I miss? It might just be runtime. To answer Masood's question in chat, yeah, I don't think we'll call it wash runtime.
Yeah, that'll work. Engine runtime, something like that. But because at least for us who have been using the platform for a while, wash is always synonymous with the CLI, and that kind of it sounds odd when we say wash runtime.
Yeah, that makes sense. We at one point Wash the CLI was also going to always have its own runtime for dev and plugins, and where we've landed is basically a consolidated Wasm Go Vroom crate could also be a great name for it, but yeah, runtime engine will work. Yeah. I also want to highlight issue of the week. Late breaking, but I put this in 2 weeks ago, and then Jeremy here started working on an implementation. And if you want to check it out, he's got a draft PR up. There's more that he wants to change on it, but it's pretty exciting if you ask me. Jeremy, you want to say anything about it?
Yeah, no, thank you. Yes, I've been working on this for the past week. Looking forward to getting this ready to go for a demo on the next wasmCloud Wednesday next week. But yeah, it basically provides from your wash component to do OpenTelemetry on the inside. It goes down. I'll show how it uses the wash runtime host, and then uses the exact same connection for doing your telemetry and stuff like that.
Yep. Any questions for Jeremy on this one? I guess, hey, Jeremy, do I have to use WASI OTel to do OTel on the host at all? Like if I'm just writing a WASI HTTP component, do I have to use WASI OTel?
No, you don't. That is correct. Yes. By default, it is off because OpenTelemetry can be noisy.
And so when it's really useful to bring this in, it's if you want to basically enrich the context of the OTel that you're emitting. So we're able to do a lot of things with the built-in plugins into our hosts and have OTel basically wired up for them. But if you want to do special things on the inside of your component, that's when you would want to import WASI OTel. And so I'm really excited to see that one. I know this is a feature that's been requested a ton in the community, so I'm glad we've got that basically cooking and coming in soon. Aditya has a question in the chat, which is, are we planning on including the gRPC support in the V2 release or for the next point release? I'm fine with anything, just checking. Right now, I'm letting Lucas, he's basically running point on reviewing PRs and getting things landed. Essentially where we're at is that could definitely be an additive change. It's non-breaking. So it's definitely a good candidate for something that could be scoped out of what's MVP, but also something that we definitely want in.
Yeah, and to add to that, I think the overall structure of the pull request is good. It's really that it drifted from what we had in before. I remember that one of the challenges was also related to the fixtures or some stuff that we were bringing in related to Wasm time WASI. So if we can time box that to this next week and figure out how to solve those, then I would say let's get that on 2.0. The issue with Wasm time WASI is going to take a bit longer to resolve. So I think here we either going to have to wait for Wasm time WASI resolution or kind of bite the bullet and implement the way that with the test infrastructure that we have inside the Wash repo. So I know this gets a bit into the weeds about the pull request and all, but it's kind of to say, yes, we want gRPC to be there, and we would love to have that in V2 proper. But also, if things start to get too complicated, it's okay to come in a point release as a follow-up.
Yeah. Oof. Okay. Yeah. That's getting into the details, but probably it sounds like we need some pairing time to see what it would take. All right. Well, unless folks have other questions on that front, I'd also love to give a bit of a WASI update. So just kind of a general WebAssembly community. Yesterday I released WASI 0.2.10, which could possibly be the last WASI P2 release. Later this week, I am planning to cut the next WASI P3 release candidate. But over the past month, WASI P3 RC on January 1st, or not January 1st, January 6th, 106. That release candidate has rolled out to a whole bunch of places, WASI SDK, Wasm Time. It's in the latest Wasm Time release. And well, all over. And we've revved kind of all the toolchain to be able to work with that. And that's the first RC that included basically the completed component model ABI. We're not expecting more changes on that front. And so once I cut the RC this week, that might be the one as well, which is very exciting. It might also not be the one. We might learn things and do it again, but we're not going to be making changes to the ABI level. It might be tweaks on the WASI interface level to make something more ergonomic for working with async and features. Specifically, right now we're iterating in the file system space, but once that is done, we're looking up, as early as a vote in March. I'm hoping we can pull it off. So, without further ado, I'd like to pass it to Elizabeth, who made a pretty cool demo on top of that release candidate that went out in early January.
Yeah, let me share my screen if it works. Can you see this? It's probably tiny.
I can see it.
Cool.
And also, y'all, check out that really awesome README.
Yeah, this is the repo. So feel free to take a look at this. I think that you also linked this in the meeting notes. So this is the repository. What it's doing is something called component interposition. So really what I mean there is taking some service that's running on top of WASI P3 and you're interposing this middleware in between the HTTP call and hitting the actual service. So you can kind of think about it like this. So there's some incoming HTTP request. And originally you would just hit the service and the service would respond back to this request. But what we're doing is interposing this middleware in between. So when this service comes in, or sorry, this request comes in, it hits the middleware first, which then continues on into the service call and then falls back out to the middleware and then back out to respond to the ultimate HTTP request that came in. So I've gotten this working so far, and I'm going to demonstrate that in a second. And I've also gotten this structure working where you can interpose in middlewares on the request that goes into a service. So you'll hit your first middleware, your second on into your nth middleware, and then hit your service, and then flow back out in the same way. So it's almost like this onion where the M1 is the outermost layer of the onion going into the service that's in the core of the onion, then falling back out. So yeah, there's a lot of details in here to try to help solidify some of the stuff that's going on at the low level. It even digs into the WAT if you're curious about this level of detail. Yeah, a lot of people don't need this level of detail, but if you're curious and you want to know how to do more complex scenarios, this is going to be very, very helpful because it'll contextualize the WAT of not just the service, but also the middleware itself and how it looks, why the world looks like what it does. And what the full composition WAT looks as well. So hopefully this helps solidify some of like the low level details if you're interested, but you don't have to know it. Yeah, so I can go ahead and show you. This is just the clone locally. And yeah, so we have a really basic script to try to help, like, there are a lot of things that are going on here, so this will just make it easier to run. So if you do this, it'll just default to running everything, which builds out your middleware, builds out your service, does the composition, and then runs the composed component. So it's checking the environment to make sure you have all your dependencies. It's building out all of these, they're all like Rust crates. And then it does the composition and executes. So this is doing that, this type where you have a single middleware that's going on and before the service is hit. So you can see that it entered the middleware and then it hit the service, then flowed back out. Which, if you look at the code of the middleware, it makes sense. Like this is the HTTP handler. So this is what gets executed when that HTTP request comes in. It does this log of entering the middleware, and then it just hands that response directly, or sorry, it hands that request directly to whatever has been hooked up, which in this case is the service. But note that the middleware doesn't really know that. It's just like passing along to the next handler in the chain, which in this case, we've hooked that up to the service. So it passes it on to the service, and then it flows back out with the response and then goes back out the same way. So you can kind of see like a little more of the low level details there. So that's for just the single middleware. And if you do multiple, that'll switch it to now doing this like multi-level tiering. So now you have something that looks like this. It's interposing 3 different middlewares. It's the A, B, and C. They're doing like really basic things, but it kind of helps with the demonstration to just have like the most basic example. So now you can see this looks kind of like the onion, like I said before. So you have the outermost part of the onion, middleware A, to B, to C, going into the service, and then flowing back out in the same order. Yeah, so that's what I have so far. And for the next iteration of this project, I'm wanting to do something that you can think of it as like splicing middleware between 2 services. So let's say that there are 2 services that have been configured to directly communicate with each other. So you have service A, and it is now directly like passing information to service B through like the HTTP interface. It's not going through HTTP though. It's literally calling into service B's like exported component functions. So if that's happening, then this structure doesn't really work, right? Because we are composing a middleware with a component that's like literally just a single service that has like the service exports. So doing this, you would have to basically splice this middleware in between these 2 services that have been composed together. So that's what I'm going to be doing in the next iteration of this project. Yeah, I think that's pretty much the full demo. If anyone has questions, like feel free to ask. I think you're on mute.
Yes, I was. This reminds me of AOP. I don't know if anybody remembers AOP, but that's the aspect-oriented.
Yep, it's like you're basically what are they called? Point cuts. It's like the HTTP call is like the point cut that you're like interposing on in AOP.
Yeah,
And
it's similar to a lot of different approaches. We're calling it service chaining for what it's worth, folks. Now, and this is a specific specialization of that of calling something specifically a middleware, and where we literally have a world that says I'm trying to be a middleware here, and we have another one that says I'm trying to be a client, and another one says I'm actually the service. I'm the main app here. But the pattern of being able to take WASI HTTP with WASI HTTP with WASI HTTP, that's an HTTP service chain. And yeah, because we're just calling our WIT interfaces here, we're not dropping down into a network stack. Go ahead, Frank.
yeah, I was just thinking from the point of view also, I mean, from a use cases point of view, is actually how to inject either debugging information or tracing. So it goes back into OTel and so forth. So then you can control all those things through. So I think this is this is nice.
Yeah, exactly. Like that's kind of where we wanted to go with this is like the basic demonstration of we can do the thing and now we can do really interesting things with this like component interposition. Like you could do observability, you could do security protocols, you could really do whatever you want to do because you would have like full control over the incoming and outgoing requests.
Yeah. Do you are you going to also spec out let's say failure modes?
Um, yeah, I guess there would need to be some type of like guarantee that whatever the middlewares are doing, they're adhering to whatever modes are guaranteed by, I guess this would be more like a platform type thing. But it could also be done with user space as well. So I guess it would just depend on the context for failure modes.
Yeah, in this case, we actually pass around a result. So that's where you would pass around whether or not an error had occurred here in the flow of the middleware chain. But I imagine that you're also probably thinking, like I was thinking, which was, oh, this can replace basically what we do with sidecars. And so it could do a lot of other things, like even potentially service breaker type injection, and a lot, basically anything that you would today put in a somewhat heavyweight Envoy sidecar, you can probably stuff it into this type of interface, which would be
Yeah.
really powerful.
I'm wondering from the point of view of guardrails and so forth. So if you're thinking the BPF that a function cannot live more than such a period of time and it has to respond, it has to do something. So
Mhm.
nothing really takes over the thread here.
In that scenario, a lot of that control has to happen at the host layer, effectively, and all of that will be in our WASI HTTP plugin implementation in our host.
Are you thinking in terms of a language for how you compose those M stuff?
Oh yeah, show that.
Whack. It's just using whack if you've seen that it's like a DSL for composing components. This is actually pretty readable. You're instantiating your service component, and then this exports what is imported by the middleware. So if you look at the WIT for the middleware imports a handler and it exports a handler. That's like really the secret, like the sauce of the middleware. So this is what it's importing whatever the downstream call is. So it's literally like, let's do it side by side. So this handler.handle is the downstream call that has been plugged into this import of the world of the middleware. And then when it exports the handler, it is just saying, I'm also exporting a handle function. So that's how it does like that service level chaining, like Bailey said. And so when we see this in the WAC, we're instantiating the service, and then we're plugging this import of the handler into we're plugging the services export handler into the import of the middleware. So we're like chaining them together. And then in order to satisfy this export handler, we then export this handler from what we just created, this like new chained middleware instance. So it's like creating that chain. And then if you look at the multiple, it just does that n times. So we take our service, we plug the handler into the innermost middleware, the middlemost middleware, the outermost middleware, and then export for the outer. So like that's why A comes first. We enter B, enter C, the service, then flow back out. So hopefully that it like helps you kind of see what actually is going on.
Yeah, actually, you could have a graphical tool in terms of composing this.
Yeah, you could do it graphically for sure. And what's nice is that you can also like generate this like from a user standpoint, you don't really need to know these like low-level details because It's just chaining these services together. So you can make this configurable, and then we generate this whack and run the whack on the component so that it just works magically.
Yeah, great.
Yeah, and one of the goals of WAC itself is to be machine readable and writable. So you can imagine, as Elizabeth basically just said, we could also generate this. I'm also just throwing out that if people want, components themselves are declarative. They're very clear about how they're linked together. If somebody was really cool, they could make a tool that created an ASCII mermaid diagram of how components are linked together. That would make me very, very happy. Anyways, any other questions for Elizabeth here? Oh, well, awesome. Thank you, Elizabeth. I really appreciated that. And even the what part, it's relevant in that, earlier I was like, we're gonna not change the ABI. And then you go and you pull up the what and you're like, that's what I'm talking about. You know how it prints that out? That's the ABI. That's what we're saying we're not gonna change. And changing imports and functions, that's actually that's pretty easy to update and change. And that's the layer we're iterating at now. So a layer above, thank goodness. So anyways, yeah. We also have somebody else that wants to jump in and share a project that they're working on. Marcin, are you able to, let me make sure I give you co-host so you can share your screen.
Yeah, 1 second. Can you hear me?
I can hear you.
Great. I have never used Zoom in my life before. This is new. Yeah, so thanks for the opportunity. I think that, let me share my screen. Hopefully this works. Can you see the Wasm edge?
Yep.
Oh, it's actually a crossfire. I know that you are from Wasm time, but so what I'm doing is basically I'm building the C advisor for WebAssembly. And I was initially, when I first heard about WebAssembly a year ago as part of my PhD, I heard all these wild claims. And I know that this is not you guys, this is Wasm, but if you go a bit further, you will very often hear claims that Wasm is faster, stronger, smaller memory footprints. And so I wanted to test that. And what we did in Orange, also part of Orange Innovation Poland, is I compiled some of the services that we use internally to WebAssembly, and I wanted to test them. And I very quickly realized that there weren't enough. Well, I was basically looking for a C advisor equivalent. I wanted to run my services. And then I wanted to see how much resource consumption they actually need comparing to containers, or maybe even comparing to bare metal. And I didn't really find anything like that, because if you start with the runtimes, Wasm time will point you towards perf. And that's good, but that's not really what I wanted. Because I didn't want to use a wrapper. I did also want to have the metrics available independently of the lifecycle of the service itself. And so Wasm time sent me towards perf. wasmCloud mentions metrics, but these aren't really anything that would point me towards resource consumption. And Wasm Edge does something called gas, but this is, from what I understand, more or less CPU instructions equivalent. And so I did what I could. I built my own version that basically inspired by, so what C Advisor does, as you probably know better than I do, is it reads from the sysfs C group directories. And that's very good because, well, containers can isolate and run everything in C groups in their own namespace. Wasm doesn't really do that. And what that means for me is basically right now what I did in my article and what we do in Orange internally is we also read from, we do what PS utils does. I basically take the PID of a running Wasm instance. That could be Wasm time, Wasm Edge, anything that has Wasm in the name or is the runtime. And then what I can do is I can get the CPU and memory usage and other stats for the process that includes both the runtime and the instance of the Wasm file itself. And that's a start, but that's not really what I want, because what I would like to achieve is basically read only the resource usage of the instance itself. And based on all of this that I've shown you, I'm sort of at, I don't really know how I could achieve that. I've looked at eBPF, I've looked at a few different options, but nothing is really as clear-cut and simple as I was hoping. So this is where I am right now. I'm looking for a better information source, basically.
Yeah, and Elizabeth, I'm also curious if Ben has anything in his space as well for at least measuring wizard potentially as well. But for us, like where my head's at for this type of problem would be very much to use metrics with OTel and potentially us establishing a convention around a semantic convention in OTel. Now you're looking at the state of the world in V1, which you've heard we're very close to launching V2. And last week, actually, I believe it was last week. Am I crazy? Was it 2 weeks ago? We demoed OTel support, and we being Lucas demoed it within our host. And that has some of this, but really it doesn't have what you're looking for yet, but is definitely something we want to add. There's also the weird outcome. I forgot the computer science name for this, but when you start measuring something, it gets slower. Like you don't actually get the real data on it. That is super duper true if you do gas instrumentation. So big heads up on that one. The folks that are using gas are getting throttled way down because the people that are using that are using it to basically deal with money, and the crypto environment for the most part is where gas is getting used, and so they have to be very correct and deterministic, and that can be pretty expensive. Well, actually, gas is implemented in different ways in different runtimes. So it's not just measuring off of gas for Wasm time probably won't give you the same result as what you measure in Wasm Edge. Now, if you did CPU instruction counting from just WASM instruction calls, maybe they should be the same. But hey, thank you, Aditya. It's called the observer effect. But yeah, Elizabeth, if there's anything you want to jump in, those are all my main thoughts there. This is pretty cool.
Yeah, I'm looking at Wizard. I can't, like, the CLI doesn't say what the different metrics are that Wizard has. Also, by the way, Wizard is a specific WASM engine. It's kind of like a research engine for WebAssembly. So like kind of newer ideas are implemented here to experiment with them. And it has a lot of nice capabilities for dynamic instrumentation. And there are really nice metrics around the engine because it's like for research reasons. So you need to have like good observability of like what is actually happening inside it. And I'm trying to find the different metrics that are available, but hold on, I'm looking in the source code. So continue talking.
Well, also it's also kind of cool to connect y'all. Marcin, Elizabeth is also a PhD student, or yeah, it sounds like maybe you have already graduated, but nope. Okay, you're PhD as well.
Yeah, it's kind of lucky to run into you because I think I've watched one of your talks, and it does seem like you'd be the person to know how to achieve that. I just also wanted to say that CAdvisor was merged into Kubelet, and wasmCloud's hosts are sort of similar to Kubelet from what I can tell in some ways. And even going back to, I think your talk, Bailey, about the density of the services that you could run with Wasm and Kubernetes, I'm sort of still need like that killer measurement data to show, for an example, inside Orange for our guys to be like, yeah, sure, let's invest X months into compiling everything that we have into Wasm. And so I'm sort of surprised that this hasn't been done yet. And I was hoping to join this call, tell you where I'm at, and then you tell me that either somebody has done it or why somebody else has failed doing it.
I can show you some other tests, but there's not ones that are cross runtime is part of the challenge. But go ahead, Lucas.
Yeah, and I think there's plenty of good stuff here. And the angle of looking at WebAssembly and saying, well, want to be the cAdvisor of WebAssembly. The way to achieve that, the fastest path would be to make WebAssembly behave like a C group normally, and then use the same paths that you already have in cAdvisor. Now, the challenge with this is that most of the runtimes, they are heavily async, which means they are multi-threaded, which means they cannot pin each thread to a specific C group to guarantee that they will be living just in that zone. So it's a problem that there's a dude that documented kind of the what's the challenge is there, and which means the first thing you have to do is make the runtime have the ability to pin a component to a specific OS thread. And this is what this guy here is solving. Once you do that, adding the thread to a C group is trivial. Now, and this is pretty much to say that this could be put together. And maybe if we get a transcript of this call and just tell Claude kind of the things that I said here in the past 30 seconds, it would be able to get that put together. It's not really that complex. Now, the other angle of looking at this is, does WebAssembly even needs something like cAdvisor? Because everything that we're doing in WebAssembly is already starting with limits. They have limits kind of baked in the ABI itself. So when we are about to give a component a section of memory, we tell it, here's your memory area, and you can grow this memory area up to 1 meg. If you go above this, really doesn't matter if I have more available, I'm not giving it to you. So I think a bit of the disconnect here is that all this information is not being surfaced in OpenTelemetry, in metrics, in any other layers. So knowing what's happening inside the runtime is challenging. With wasmCloud v2, we're addressing pretty good chunk of those challenges. We are not addressing yet the challenge of saying this request used 3 megs of memory. So get to the point that we can say every single HTTP request is taking this many CPU cycles and this many memory consumption. But we have all the kind of bits in place there, and I think with WASI P3, it's going to be easier to get these things more mainstream. Thanks for coming to my TED Talk.
No, I see that. Yeah, that's for our guys in Orange, that was something that we needed basically. And while the linear memory model, or maybe even the memory pages of WebAssembly basically would often mean that you don't really need to read it, as you could put memory limits in place for Wasm. That is something that we needed, and that is also one of the arguments for Wasm adoption that I often heard initially, like the sustainability, the similar-ish performance. That's even something that we found in our article. So I understand that this might not be the most important part, but that's something that we have very often heard when I got personally asked about WebAssembly.
And that's great. I think one pull request that we saw passing by this week, which is totally related to what you're talking about, is the fact that if you deploy an HTTP server in WebAssembly today to wasmCloud v1, and then someone else deploys a copy of that same OCI artifact, and somebody does the same, and let's say 10 people do that. In wasmCloud v1, you're going to have the same component loaded in memory 10 different times. And each request is going to be an instance of that component parsing section to that user. With wasmCloud v2, we keep track of the artifact that is being loaded in memory. So if we have 10 people requesting the exact same OCI image, we only load it once to memory, and all the instances for serving the HTTP requests come from that single instance. So the penalty that you pay for having homogeneous multi-tenancy is very, very low. So this is to say that I think a lot of the tests here would be interesting to check against wasmCloud v2 because they'll probably be interesting. And we're pretty close there too. Oh, Marcin?
Yeah, so I was looking for a way to raise my hand on Zoom. You mentioned, what's the name of that? Is this instance sharing or the...
I'll drop it here in chat in a second.
So one thing that I think is, and I don't remember the name of the tool, but it ran on eBPF. It would actually stack up over time all the different calls, so you could see everything that's going on, and you could see, I mean, in terms of you could check in terms of if it was memory usage or it was a CPU and so forth, and it would layer from when you call a function, then what happens from all the way till it comes back. And there were some eBPF tools actually to do this. I don't know if anybody remembers this. I can search and
I think that's where wasmTime was suggesting to go use perf. Which it's I think okay for developing wasmTime itself, but not really for the end users. I think we're looking for something a bit more like cgroups, OTel, Prometheus metrics, that kind of stuff.
and anything that you can capture from eBPF.
That would be probably more, in this scenario, more for the network side of the world.
No, you can. I mean, with eBPF, you can get all the metrics also. Not just network itself. I mean, you get all the events.
Yeah, but that's where you run into the same process pinning problem, where we'd have to, I think we would have to solve that to make that useful even for eBPF.
Frank, I linked a tool we built when I was still at Capital One. It's been sort of abandoned by now, but it did a good job of surfacing the type of metadata that you get at the eBPF layer, which is primarily system calls. And WebAssembly as an abstraction is going to be sitting well above this. So I don't know that you can granularly get or pass through the the information there, but just you browse some of the screenshots, you can look at the kind of like distributed system call tracing that we were doing across fleets of Kubernetes servers at the time. So it's linked in chat there. It's called Swole. I like the little Swole gopher. It's pretty dope.
And another note, Marcin, that you might be interested in. I think, like Lucas just said, you are interested at the higher level, probably the C group or OTel path is the best one. There are micro benchmarks and basically all of the main WebAssembly runtimes. Obviously, that's how they can granularly measure each of these things. So if you look for a micro benchmark, you'll see quite a bit. And I know at least for wasmTime, that's a really great place to kind of see where they're measuring basically the overhead of using a WebAssembly component versus a WebAssembly module, problems like that. It helps paint a little bit more of a picture than what gets a little fuzzy when you throw a network into the problem.
All right, I got some notes. I have some links to see, so I am satisfied. Yeah, so I'll keep on studying this. I might be back in a week or a few to see if I'll get anywhere with this. But yeah, anyways, thanks for the time.
Oh, thank you for coming and asking. Elizabeth is asking for your email, Marcin, so you should DM that to her. And I think you're both on our wasmCloud Slack too. Is another option.
I'll cross connect you guys via email right now, Elizabeth.
Great, cool. Thanks. I have no idea how to DM, or I do.
So jealous.
Yeah, me neither.
All right. Well, that is, I think that's all of our items for today, unless anybody has any other questions or things to run through. This was a good one. Yeah, Frank.
Yeah, actually, so from a documentation point of view, I'm just wondering, because I'm interested on the Kubernetes side, and when is the latest documentation going to be available so I can just easily go through and not having to debug much? Because anyway, just
I
wondering.
think it's all out, Eric. Correct me if I'm wrong. He updated the deployment guide to include the gateway change and to pass in default, and so I think
Yes
we're
and
good.
yes and no. So because we're doing the example updates and revs right now, anything that is drawing on an example, including spots in the dev guide, are going to be a little shaky until that process is complete. The installation page, everything there should be completely good. And then all assets describing concepts, anything giving you a sense of the architecture should be or features that should all be up to date. But anything touching an example could be shaky this week as we're getting those all revved and up to date, and in some cases moving them around from one repo to another and things like that.
Okay, cool. Thanks. Actually, for performance that I was looking for is called Flame Graph.
Oh, yeah.
I want to say it's been a while, but Roman presented some flame graphs about Wasm before, although I can't remember if that was on the community meeting, Bailey, or just in an internal meeting.
I don't remember. It's been long enough.
Well,
I mean, we
okay.
get flame graphs out of the micro benchmarks I was talking about from Wasm time as well.
Okay.
So if you're using some of the Wasm time performance testing suites, it's there. I also believe we have it in the Bytecode Alliance SiteGlass project, which I'm sure you ran into, Marcin, but that's very Wasm time specific.
Not sure if I have, but it doesn't necessarily have to be cross runtime for me. So that's not really a requirement from like a
Well,
research standpoint.
Then definitely check out SiteGlass. I just dropped a link there. It's basically where we put all of our benchmarking suite and tooling for both Wasm time and CraneLift. Basically, when we have a monthly cadence of cutting releases, and we cut about 2 weeks before the actual release will go out. We cut the release branch, and that's when it undergoes extensive fuzz testing for continuously for 2 weeks, and it also runs through this benchmarking suite.
Okay, great. So I'll check it out then.
Yeah, and it's all based, a lot of the folks that created this also worked at Firefox, and their like gold standard is the "Are we fast yet?" webpage, and yeah, flame graphs galore. So do look at those and enjoy them. Yeah. Okay. Well, thank you everybody. Appreciate you coming. Next week, I think we'll have even more things to show because we'll have lots of templates probably by then.